Okay, so we are going to start with our dilation notes today. So everyone has this packet. We are going to fill in the blanks as we go along. Okay, so blank is a transformation that produces an image that is a blank shape as a pre-image, but is a I'm going to go ahead and put it in since I said it, different size, either larger or smaller. So what kind of transformation are we calling? Yeah, it's a dilation. A dilation is a transformation that produces an image that is the same shape as the pre-image, but is a different size, either larger or smaller, right? Yeah. Same shape, we just make it big or small. Okay. When we make things blank using a dilation, we refer to that as either an expansion or enlargement. Yeah, if we make it bigger, we call that either an expansion or enlargement. If we make something smaller, we use the term contraction or reduction. Okay, when the dilation is a blank, the scale factor is between 0 and 1. When the dilation is a blank, the scale factor is greater than 1. So it's an enlargement or expansion either way. Okay. What that means is if you have a scale factor of 3, or sometimes written as 1 to 3, the image is 3 times bigger proportionally to the pre-image. Okay? So let's look at some examples of what that looks like. I'm going to move this over there. We got a penguin and a map of the United States, somewhat. An outline of the United States, really. All right. So, as you can see, the pre-image and the image, the penguin got smaller, and then from pre-image to image, the image got bigger for the United States outline. So we have an example of a reduction and an example of an enlargement. Okay. So when the dilation is a contraction, reduction, however you want to say that, we've got 2 options there. I'm going to put reduction. The scale factor is between 0 and 1. Okay? What this means is that if you have a scale factor of 1/2, or that's sometimes written as 2 to 1, the image is half the size proportionally to the pre-image. Okay? That word proportionally. Okay, so what would happen if your scale factor was 1? Yeah, so nothing. If you have a scale factor of 1, nothing changes. When you multiply anything by 1, it maintains the image. It would be like if you're rotating an image or rotating a pre-image 360 degrees. The image would be the same, right? It's an identity transformation. What do I mean by identity transformation?
You just change it to A prime, B prime.
Right, you didn't change anything. It's like if you added 0 to something, or if you multiplied anything by 1. Those are identity properties. Yeah. All right. Moving on. Oops. Okay. So here's an example. What happens when the shape is dilated? So the length of each side is equal to the length of the corresponding side of the preimage multiplied by that scale factor. Okay? So, what was the length of AB? What's the length of A prime, B prime? What's the length of BC? What's the length of B prime, C prime? What's the length of AC? 5. What's the length of A prime, C prime? So we can rewrite these as 1 to 3, 1 to 3, 1 to 3. So what's your scale factor here? Okay, otherwise known as 3, right? Your scale factor is 3. This triangle over here is 3 times bigger than triangle ABC. Triangle A prime, B prime, C prime is 3 times bigger than triangle AC. Okay? So if we had a dilation center, what have we called our centers? And yeah. So how have we noted that?
0, 0.
Not 0, 0 necessarily. How have we noted our centers, like when we were doing transformations? Point O, right? So a dilation with center O. Anybody remember from doing partitioning line segments how we denote scale factor? No? With a letter. Okay, so that's the point we're going to. How do we denote the scale factor? It's a... Okay. There was a letter we used to show that though. K, right? So if we have a dilation with center O and a factor of K is the scale factor, or sorry, is a transformation. K is a scale factor, but dilation with center O and scale factor of K is a transformation that maps every point P in the plane to point P prime. Okay, so if you had any point hanging around here, B, right? Well, we multiplied this distance by K and got B prime. We had this point C, and it was X away. We multiplied X by K and got C prime. Okay? So whatever distance you are away, multiply that by your scale factor and you'll get your dilation. Okay, so let's look what this looks like with different types of points. Okay, so in the first case, if P is not on the center, so if P is not the center O, origin, then P prime lies on the ray OP, so the way we denote that, on OP, ray meaning, do y'all see how we put that arrow above OP? L-I-E-S, lies. Lies. It's not super easy to write with this pen. On ray OP, the scale factor K is positive. Okay? So K would look like OP prime over OP. So we have this point P prime that lies somewhere on OP prime. So do y'all see we have point P out here, right? Okay. So P prime is on this ray, and it's past RP, right? That means we have an enlargement. If it's not past RP, then it's a reduction. Okay, that's all this is saying. If this distance from O to P prime is bigger than O to P, you're going to have an enlargement. Your scale factor is going to be greater than 1. If your O to P prime is less than O to P, then it's going to be a fraction in between 0 and 1, but it's still going to be positive. Okay. Let's look at our second property. So we've already looked at if P is not the center, right? So what's the other option? P is the center. So if P is the center, then P equals P prime. If P is on the center of dilation, then it doesn't move, right? Because there's no distance away from the center to multiply. What's your distance away from the center if you are the center? 0. What's anything times 0? 0. The center of dilation doesn't move. Okay. So the last thing I'm going to get on this portion of video, because I can only do 15 minutes at a time. So the last thing I'm going to talk about is how to denote dilations. Okay. So think about when we were denoting transformations and we had translations, rotations, and reflections, right? What did we all start off with? There's something we put right here. Okay, so what was it when it was a reflection? What was it when it was a rotation? What was it when it was a translation? So for dilation, what's it going to be? D. Okay. All right, so D for dilation. Then you use your dilation center O, dilation center O, and what's the other part of a dilation? K, your scale factor. So, from a dilation of wherever your dilation center is, which may or may not be the origin, y'all keep saying origin, it's necessarily a 0, 0. It can be anywhere, okay? So then you have X and Y. So basically what you're doing is multiplying your scale factor by X and your scale factor by Y to get Kx and Ky. Okay, one thing, make sure that you multiply each of them, right? Not just one of them. All right, so we're going to stop there for a second.